Hello, everyone. Thank you so much for being here today, in person and online. My name's Alessandra, and I'm the Community Engagement Librarian at the HKS Library. I'm joined by my colleague, James Capobianco, our Research and Data Librarian, Megan Kelly, our Research and Data Services Assistant. Hello. And online, we have James Adams, who's our Manager of Research and Data Services. And I'll let our user group folks introduce themselves as well. But do you want to do it right now, or do you want to do it after I'm done with my spiel? Okay, beautiful. So we're doing like a joint venture today between the HKS library and the R user group because we run a series called Data and Donuts, which has been going on since fall 2018. We invite researchers and practitioners to talk about their work using data and on issues of data and society to give folks at the Kennedy School and beyond more of a way to engage with data at like a high conceptual level and talk about it with peers and build community. So our missions align really well with the R user group, and we're so excited to have a joint event today. Just some really brief housekeeping before I give it over to Christian. So as you know, we're doing a hybrid event today. That means that if you're speaking, if you're not doing it into a microphone, no one online can hear you. So if you have a question, please wait to have a microphone in your hand. I will happily bring one to you. But just keep that in mind. And then we're going to have how many speakers today? 4. Cool. We'll have like a brief period of questions after each one. So just hold for them to finish their 5 to 8 minute presentation until that. And I think those are all the things that I have to say. I guess the last thing I should say is that if you like what you hear today, we have one more data and donut session coming up next Friday at 10:30 a.m. It's going to be with a woman named Kaylin Boyd. She is a project manager at the Institute for Quantitative Social Science here at Harvard. And she's going to be talking about the first large scale library collection that they digitized and turned into a text-based corpus to do data analysis on. So she'll be talking about that process, which should be pretty cool. Okay, I'm going to give it to Christian to talk more about the details of how things will work today. Oh, yes, please take this.
Thank you so much, Alessandra. So welcome, everybody. Thank you so much for joining us for Lightning Talks with Data and Donuts. I'm Christian Testa. Online is Nicole Swartwood and James Adams, and you just met Alessandra Sater. So Nicole and I organized the R user group, which we founded in 2021 with the Harvard Data Science Initiative to help support the R programming community around the Harvard University area and the wider community. And so if we haven't met before, let me just tell you a little bit about what we do. So we organize talks and guest lectures from influential members of the R programming community, as well as host talks to provide opportunity from people from our local community to practice giving talks and talk about things that they're excited about, as well as host social events for us to connect. So everyone is welcome to join, not just people with HUIDs, so to speak. And we'd encourage you to subscribe to our mailing list, which you can do so in person here with the sheet, or you can scan this QR code. Additionally, you can follow us on Mastodon, where we're at rug@HDSI. So today, please bear in mind that the speakers and what they present do not represent the views of Harvard University. This event will be recorded like our other events and shared on YouTube to promote the free knowledge about our programming. And the recording will entirely focus on the speakers, so people up here at the podium and what they screen share. So the audience isn't really captured too much. And I want to encourage you to get involved with the Harvard Data Science Initiative or the Data and Donuts series if you haven't been before. And I just want to mention before we get into it that at the end, we'll have a couple of raffles. So if you want to enter the raffle for R for Political Data Science, a physical copy of the book, that's available up here. There's also Advanced R up here. And for people on the Zoom, there's a entry for a raffle online, a Google form to win a copy of R for Data Science. Also, our best lightning talk, according to an audience vote, will win a $50 Amazon gift card. So without further ado, let me introduce Andrew Ghazi, who is a statistical geneticist at the Center for Computational Biomedicine at the Harvard Medical School, who will give us a brief introduction into the Center for Computational Biomedicine's NHANES+Stan Docker image.
display scaling. There we go. Okay, pretty good. Just going, whoops. This will do for now. So yeah, hi everybody. Actually, let me get the speaker view going. Where's the mouse? Okay, yeah. Where's my mouse over here? Okay, yeah, so hi everybody. My name is Andrew Ghazi. I'm a statistical geneticist at the Center for Computational Biomedicine at Harvard Medical School down at the Longwood campus. I'm going to be telling you about the NHANES+Stan Docker container that my group has been working on. I'm first going to give you two pieces of separate background information on two separate topics, and then tell you how we've been kind of combining those two things into a tool for epidemiology research. So the first thing is NHANES, the National Health and Nutrition Examination Survey. This is a huge data set that's been collected by the federal government over a long period of time. So it's hundreds of biomedical variables like questionnaires, blood lipid levels, just a huge amount of stuff collected from large cohorts of people like 5,000-ish every 2 years, going back to 1999. And intermittently back to 1959. So it's the kind of data set that only the federal government could collect. And yeah, it hits really rare, kind of understudied groups sometimes. And it's all publicly available through a web interface that only the federal government could devise. So yeah, a lot of separate SAS transport files and the variable descriptions you have to scrape from the HTML web pages. So it's pretty easy to access any one slice of variables, but accessing the whole thing is pretty difficult. So that's thing number one. The second thing is Stan. Stan is a probabilistic programming language. That's its main feature is adaptive Hamiltonian Monte Carlo sampler. This is used for fitting really complicated Bayesian models really quickly. And like R, it's kind of by and for statisticians. So there's evolved over time an ecosystem of packages surrounding it, things like command-stan R, tidybays, berms, and so on. So that's thing number two. And so what my group has been doing through a project called Epiconductor is assembling some Docker images. So the main image is available on our GitHub page there. And it provides in a single Docker image R, RStudio, tidyverse, as well as a SQL Server installation that has access to a fully scraped snapshot of all of the NHANES data. So it provides like clean, sanitized, programmatic access to the whole thing. And then kind of a mini project that I've been working on recently is a second image that adds Stan functionality. So you can install Stan, all of the berms and Lua and all the accompanying modeling packages, as well as some quality of life things. Both of those images are available on our GitHub page, and they do all of the downloading, installation, configuring with just 2 commands. So it's much easier than setting it up all from scratch. So this is what it looks like when you have it installed on your computer. It's just you just kind of access it from the browser. So you just go to localhost. And yeah, it opens a demo analysis script. It links out to the documentation, dark theme, and has all the nice stuff to make it easy for epidemiological modeling of the NHANES data. So this is kind of just a micro walkthrough of that little script. So you load the tidyverse. The NHANES package is what provides programmatic access to that database from R. Here I'm just searching for variables related to HDL. And then once you've identified the variables you want to pull out, put those in a list. And then you can call this function joint query to pull that information from the database. And then I'm using dplyr to filter out rows where it's or NAs. And then we can fit models. And so this berm function is the main function from the berms package, which uses Stan. Here I'm comparing two models for HDL levels that include an interaction of age and gender. And then the second model includes also a term for log triglyceride levels. And once you fit those two models, you can do leave one out cross-validation model comparison. Yeah, so that's it. This is the link to our website. Yeah, thanks.
We budgeted time for like 1 or 2 questions for each talk. If you're online and you want to ask a question, please raise your hand and we can hear you in the room. But if you're in the room, please also raise your hand and we will be able to hear you in the room.
For the variable list, would you still go to the HTML and just use the same names from all of that? Or is there also like in the GitHub a list of everything or a way to like print all the variables that are related to something?
I believe there's a function to just print all variables. I usually use this NHANES search one to find related things. It also, I believe, searches through like the variable descriptions. Yeah.
So do you have a like application of this that you're really excited about that's in the pipeline, like something that you're about to do with this?
I haven't personally developed anything with this. The main kind of mission of CCB is to like enable HMS researchers to do things with tools like this.
Great.
So, yeah.
Okay. Thanks. Oh, great. Oh, go ahead.
Yeah, I was just going to ask if there were any plans to expand this to other databases that might be of use, like the American Community Survey or population estimates.
Not right now that I'm aware of.
All right. Okay. I think we'll switch over to our next talk. So thank you so much. So next we'll hear from Sam Kuhn, who's an economist at Appcast, who will tell us about how to save hours of time with parametrized Quarto reports.
And this is probably a bit of an exaggeration. I tend to do that. Maybe it's not hours, maybe it's 20 minutes, maybe it's 10 minutes, but hopefully it save you a little bit of time. So just a quick bio. I'm an economist by trade, but really I'm an R programmer by heart. I love R programming. I first learned about Quarto at PosiConf in 2022 when JJ Allaire announced this new initiative, the shift from R Markdown to Quarto. And when I heard about it, I sort of like, it took me a little bit to process it. And I went home that night after a few drinks at the hotel and I was like, this sounds really cool. There's a quick picture of me. A quick question. Who here uses Quarto in their work every day? We have one person, 3 people. Just a brief background. It's effectively the successor to R Markdown. It's the new modern version that supports Python, Julia, other programming languages. So I want to start with a problem statement, which is if you need to collect a subset of data or analyze or visualize data, and you need to do it over and over and over again for different people for different types of work, it's a kind of a pain in the butt, right? You get requests from someone else. It's like, hey, I need this report. I need this type of data. And it's coming from one data source, right? You start to think like there's potential for a lot of automation here. So really that's the beauty of Quarto. And I'll explain how what that solution looks like. So what is that? So when you create a Quarto document, you have this what's called a QMD file, and within the YAML headers, which is where you sort of declare like what you're creating. So I'm creating an HTML file, I'm creating a PDF. You can insert what's called parameters, which allow you to dynamically change what the document is creating. So here's an example. This is just a parameter for year. So imagine I have to create 5 reports, one for a different year. I can plug in those parameters and then I can return a bunch of different reports all at once rather than like doing that a bunch of different times across like 5 different R scripts. So here's what that looks like, this YAML header. So for example, the case study we're going to talk about today is BLS data, Bureau of Labor Statistics unemployment data. So just this is my YAML header, so analysis of US unemployment rates. I want to return a HTML file, and then in my parameters, I have 2 different BLS series IDs for different types of unemployment rates. And then I'm going to, I actually only want it for a period of 4 years. So this is where the document actually is like effectively the metadata of the document. So how does this actually affect your code? So if you've ever had to do an API call to the BLS, the census, I've done it hundreds of times, this is probably what your code looks like. Is like you're manually inputting in, you know, the series ID, this series ID, and you're fetching that data. It works great, but let's change it to this. So this is dynamically inserting that data you put in the YAML header file, but you're not changing any of the underlying source code. So rather than just constantly going back and forth to the function you're writing, just go to the YAML header at the very beginning of your document. It'll be set for all of the R code you wrote, and then you're not changing the underlying source code at all. So actually, I wanted this data to 2015. I go to my YAML header, change it to 2015, and I get that data back. So for those that use ggplot, it turns your ggplot code and makes your ggplot code look like this. So here I'm using glue statements, and I'm inserting the names of the BLS series IDs into the chart itself. Rather than using the actual, like rather than changing the title, now here's the unemployment rate for 16 to 19-year-olds, 20 to 24-year-olds. I'm not typing that out. I'm using it from the parameters of the YAML file. And then here it is. Voila. This is just an example. Let's try this live. I just heard so many people shiver. So this is my YAML header file. So what I'm going to do is I'm going to use the Blastula R package, which emails people stuff. So I have a header for my email, the person's name, the BLS series IDs, and then when I'm going to pull the report.
Could you zoom in just a little bit?
Yeah, 1 second.
Thanks.
So all this script does, I'll walk through this very quickly, is it does the exact same thing. It fetches the data from the BLS API, it creates a chart, and then it sends an email to whoever wants it. So I'm just going to run this report. It's going to run for a second. Email sent successfully. So if I go to my email, there it is. So it's got my charts. And then you can imagine if someone else asks for something different, you plug in those parameters, you plug in that data, and it sends it off to someone else, and you're never changing the underlying source code. If you maintain source code a lot, you could realize why this is an advantage, because then you're not just, you don't have like 100 different versions of an R script to do the same thing. That's really the beauty and why it saves so much time. So I just want to end on pushing the boundaries of this. So again, you can iterate over many different emails using per tools. So imagine I had a list of 100 emails. I can iterate over all of those. And rather than doing it rendering that script a bunch, you can use per. And then also, I don't know if anyone here is familiar with Typist. It's potentially the successor to LaTeX. I recently learned about this. Quarto is investing in this as well. It's sort of like a modern version of LaTeX. And you can create like very, very nice academic PDFs, manuscripts, all of this stuff. And you could create these branded PDFs, send them off to people, and your life is a lot easier. I just want to end on giving credit where it's due. There's some really great blog posts from the community, how to use Quarto for parameterized reporting, tips to create parameterized reports and PDFs, and then also understanding, there's a talk from PosiConf 2023 about using Quarto reports to understand soil health. So it's really, the sky's the limit. That's it.
We definitely have time for a couple questions. So if there's anything people would like to ask or on the Zoom, please do.
We got one from Robert on Zoom.
Oh yeah, Robert, if you'd like to go ahead, go.
Hey, so I have 2 questions. One, can you send them a script that they can send out so I can play around with your template? And 2, as a fan of R Markdown, sell me Quarto over R Markdown.
Can I start with the second one? So
Go for it.
there's no, if you're a fan of R Markdown, there's no reason to not use Quarto because it's almost the exact same thing. It's 95% of what you got from R Markdown, who I just spoke with the founder of R Markdown on Tuesday. He was like, yeah, use Quarto. It's almost going to be the exact same thing, but you get a lot more customization in terms of like supporting new tools like Typist, supporting, different programming languages, obviously like Julia, Python, all these other programming languages. To answer your first question about if you could share the script, yeah, you could create a template Quarto document, and then you could share that with your colleagues and be like, hey, this is our version of this report, and this is how it's going to be created. And then you can modify the YAML as you need.
What I specifically meant was, can you share the one that you were using as the
example? Yes. Yeah, definitely. Yeah.
Great.
Okay, any other questions? Okay, then let's thank our, oh, wait. Oh, go ahead.
Sorry. We also have one from the chat, which I'll read first, which is Megan was asking if you could describe Typist and whether it was also XML based.
That's a good question. Probably not for myself because I learned about it on Tuesday. So all I know is that it's a modern successor to LaTeX. The technology behind it, I don't know much about, I'll be honest.
Fantastic, thank you. And I was also going to just ask if you referenced the glue function in the glue package, which is something I'm personally not familiar with, and I'm not sure if others are. So I didn't know if you could just describe what that's doing just a little bit more.
Yeah, sure. So has anyone used F strings in Python? It's sort of like Analogous. It allows you to insert R statements into a code. So if I want to, I have some text and I want to insert it into my R chunk, it allows you to paste that in there without having to change the underlying text itself, if that makes sense. So it just allows you to dynamically change your underlying code without having to go in and change my title every single time.
Thank you so much.
Can I ask a follow-up question about that? So I am a little bit familiar with glue, but I don't yet know. This is kind of in the same spirit as Robert's question. Why should I move on to the successor? Because I'm reasonably comfortable with some of the base R functions or stringer package. What is glue doing for me that's so much better that I should move on to that paradigm?
It's great. So stringer is great for string manipulation, right? Glue strings are a very specific thing. Just if you have a bunch of text, and I'll just go back to my example. So here's this email I'm composing. So you notice where it says hi parameters name. I'm just inserting the YAML header in there, and I'm not ever changing the underlying text, right? I'm not going in and editing this string ever. It's just being dynamically updated from the YAML. So the stringer is great for if you have to do a bunch of string manipulation and horrible regex, which is a nightmare. This is something kind of entirely different, just a nice way to save some time.
Great, thank you so much. Okay, so are there any other questions? If not, I think we'll move on to our next talk, which will be, I think I'm letting Nicole introduce our next speaker, and we'll want to get the Zoom up on the screen in here.
Okay, fantastic. I'll go ahead and introduce our next speaker while the Zoom's being pulled up. Our next speaker is Sarah Hirsch, who is a research analyst at the Stanford Department of Public Health. And she'll actually be talking about how to use Regex in R for efficient programming. So I'm hoping she'll be able to show us that it isn't as much of a headache as it was just suggested. And let us know if you can see the Zoom, when you can see the Zoom.
Okay.
Thank you.
Sarah, we're going to ask you to hold on just a second so we can make sure that your presentation is pulled up in the room as well.
Okay, great.
Okay, you should be good to go.
Awesome. Yeah, actually, that's I'm going to take that introduction and run with it. I love Regex. I call it Regex. Most people, or some people at least, call it Regex. I also say GIF. Some people say GIF. I will die on this hill. But I love it. because once you get the hang of it, it's really a fantastic tool. And, also has the added benefit of, letting me feel like I'm a back-end programmer and like kind of a hacker or something, right? Not true, but it's good for thinking that, right? So what is regex? And to make it a little less overwhelming and scary, it's short for regular expression. What it is a system of codes used to generalize character strings. And it's really common across a lot of programming languages. So this is something that if you learn it and you learn how to use it in R, it'll be easy if you have to hop to Python, if you have to hop to SQL, if you have to hop to Linux or C, right? You can take this with you. And there are like little variations of it depending on what language you're in. But a lot of the basic concepts are the same, and that can be really helpful. And so it's extremely useful for data cleaning and automation. I have moved away from using dplyr because it can be slow with very large data, right? And regex allows us to utilize base C functions to analyze this data, which makes it much faster. And so some of the immediate case applications that are common are, taking out typos. Who here has looked at a data set of self-entered addresses and all of the typos that those include? You can also perform fuzzy searches on data. Say I want to find something that has an A in it, right? If I don't use regex, I have to look separately for lowercase a and then uppercase A. And that's a very simple example, right? Whenever this gets more complicated, it starts to become increasingly complex and difficult to follow. And then it allows you to conditionally loop through character strings, making functions easier and more flexible, lots of different applications. So how do I use it, right? This is a rabbit hole. So we're just going to look at the outside of the rabbit hole right now and notice that there is a rabbit hole, there is a rabbit in there. We're not going to go down the rabbit hole. But some of the most common codes for regex that I use mostly are these listed here. So one concept to know is that if you don't put either a backslash or these brackets around any letters that you write, it will look for specifically those things, right? These have double backslashes and double brackets because of our rabbit hole that I won't go down. But you do have to put these backslashes in order to escape these characters and let the language know that you're looking for a special symbol rather than that actual letter. So the lowercase d, we have digits. Uppercase D is not digits. So there's several of these that are letters. There's a whole bunch of them. So the lowercase is a positive match. The uppercase is a negative match. So not that, right? So lowercase w are word characters. The alphabetic characters 0 to 9 and an underscore. So an uppercase W would be not those. Anything that's not those, right? If you want to just get A to Z, you can do alpha in colons. If you want a blank space, you can write space in the brackets and the colons. And then we also have these markers for how many of these do you want, right? So you can use some of the symbols above plus whatever else you'd like to write and follow it by a plus sign. And the plus sign takes the last element, right? So if you're just writing out letters, it'll take the last letter. If you're writing out something in brackets or a special code, it'll take that. And then say one or more of these, right? And if there's 0, it won't match, right? Asterisk will take 0 or more of these, can sometimes not be so useful because then you just get everything back, right? And then, but it can be useful in like more complex expressions. And then if you want a certain number of something, you can put this in the curly brackets, and you can also put a range, for example, from A to B in curly brackets. And there's a way to specify if you have a range, which side of the range you want it to err on, another rabbit hole. And some of my favorite characters actually that I find really helpful are the caret and the $sign, which will anchor your pattern either to the beginning of the string or the end of the string. So if you want to anchor it to the beginning, you put caret and then whatever you want to write. If you want to anchor it to the end of the string, you put whatever you want to write and then $sign. And then it won't allow you whatever matches it comes back with will be starts with or ends with. So you don't have to worry about, you know, catching like floaters in there. So here are some common use cases. Please forgive the uneven cropping. It is what it is. But so I'll start off with the simplest one that's on the top, which is pulling variables by pattern. If anyone in here has worked with data sets with 50 plus variables that aren't in order and are not easily alphabetized or sorted somehow, that can be a pain. I'm sure we've all gone through, you know, writing out each variable by name, you know, and making a vector and, you know, but there's an easier way, right? Which is, as we see names of the data, you take the names and then subset them by something that matches a regular expression. So just real quick, the two functions that I use most with regex are grep or grepl and gsub. So grep is global regular expression print. With the L, it's a logical. So without the L, it returns the index numbers. With the L, it returns a true false, a Boolean vector. And gsub is global substitute or substitution. So basically what this first function that we're looking at does is it pulls the variable names of the data and then matches them to whatever index numbers come up matching a pattern of 2 P's in a row from those same variable names, right? So this would match if you had data like apple and pepper and banana and orange, it would bring back apple and pepper. And so if this was also a really great way to get started into learning how to set up my own or other, or, you know, collective use naming conventions, because when I name with patterns, I can pull my data so much more easily, right? Starting all count variables with CT, starting all rate variables with rate. There's many, many other ways to do it, but this makes things a lot easier. So down and to the left, we have a use case of error correction, right? So, I mean, the first thing that always comes to mind are self-entered addresses that have all kinds of fun typos. So I will, okay. So this particular code, so we have the gsub, the global substitute. So we have in the first argument is the pattern that I want. The second argument is the pattern that I want to replace it with. And then the third argument is the data that I'm using, right? And these are just different examples for dplyr, data table, and base R, because you can use it in anything. That's the magic of Regex. So basically here it's just saying anything that's not a digit, like 1 to 4 characters at the beginning of the string that are not digits, delete them from, you know, the zip code. And so, so then what we get back is hopefully, a clean string of zip codes, which if there's maybe, for example, 5 non-digit characters, then we might have one zip code remaining that still needs to be cleaned, right? But this is also a really great way to delete things on scale, right? Pattern, replace it with nothing, and whatever you're looking for. And then the third use case that's really common is filtering, right? So I was looking through NDC codes of statins, right, which is an enormous set of medications, and also includes some combined medications, right? So say I only want to look for statins. This case here, we're looking for any number of letters towards the end of the character string. So this won't pull anything that ends with a number or any other kind of punctuation or space or anything like that. And so this allows me to filter for clean data, or filter for kind of any different pattern that I'm looking for. Just a note here, I did use grepl on purpose because filter will not take grep. It needs the logical vector, and it will throw an error if it doesn't get the logical vector and instead gets the list of indices. So this is these are just some of the most common ways I use regex. If in the questions you would like any more explanation, I'm very happy to give it. But I think hopefully this has given you an idea of some of the usefulness of this particular code subset. So thank you so much.
Looks like we have a question from Robert.
Oh, less a question and more a further pitch for regex. Actually, funny enough, in context of the talk before about Quarto documents. So if you have an API call and you're trying to automatically readjust the dates, oftentimes they'll have dates listed in the API call. So regex is a great way to have it automatically replace it with your system date. And that way you can just hit run and have it re-automate that plot or that file output that you're doing.
Yes, that was one of the use cases that I thought about adding, but then I didn't want well, it's a short amount of time that we have. So, but yes, it's great in API calls.
If there's not other questions, I'd love to ask a question, and I'll try to come over here so you can actually see me. So something I've wondered about is how R's regex system is different than other languages. When I was first learning regex, I would stumble onto like the Perl equals true argument in some of those commands that you use, like gsub and grepl. And I never figured out when to use that or when not. And I don't actually know how R's regex system is any different than others, if at all. I was just wondering if you have any insight for me about that.
Yeah, there's so normally Perl isn't needed. Sometimes it's needed for more complex expressions, because what it does is it takes directly from the Perl set of expressions. Not all of them are, I guess, immediately available within the R language. On that, specifically where that boundary is, I'm not entirely certain. But to kind of understand how to use it, it's in contrast with the fixed argument, right? So the fixed argument lets you search for just whatever string you put in there. So if you put \\d fixed true, right, it'll search for \\d. right?
Okay.
Well as the Perl will, if you need it, will let you do things like look aheads and look behinds and stuff like that.
Gotcha. Yeah, I try to avoid the negative look behinds and positive look aheads and whatever when I can, because they introduce so much complexity. But I'll let Nicole introduce our next speaker if there's no other questions, or to tell us if there's other questions. Oh,
No
there
more
is one more question
Oh,
in here,
sure.
actually.
May I ask if your space is a full space versus half size space, the same as the size of a Roman letter? And I suspect it looks like a Chinese space. I do not use Apple computers to write code very much. And also, I would like to ask about the colon equal. What does that mean? And also, I have seen dplyr and the colon. Would you
Okay.
explain? Yes, thank you.
Sure. I believe that the space is a Roman character space. There is support for other language characters. That's another rabbit hole. That's a whole other rabbit hole, I think. But I believe it's a Roman character space, although I would assume that you can adjust that. The colon equal is a form of creating a new variable in data table. It mimics the mathematical define symbol. And in dplyr, remind me what the third part of the question was?
The last question was about the colon syntax. I think that you showed an example with dplyr.
The colon, right next to each other, I don't think I have up here, but that's always helpful if you want to use a function, but you don't want to load a package into your environment. You can write the package name, colon, and then the function. And that will just, as long as the package is installed, it'll allow you to use the function.
Okay, should we move on to our next talk?
Yeah.
Or,
Our next talk will be given by Robert. I realize I don't know how to pronounce your last name, Robert Sucsy.
Sushi, don't worry, it's not
Sushi.
phonetic.
Sorry about that. He's an epidemiologist at the Rhode Island Department of Health, so the other coast, and he'll be talking about how to use ggplot and tidycensus to create choropleth maps of census data.
So, hey everyone, am I off mute? And is everything sharing properly?
Yes, we
Okay,
can
great.
see your screen.
So, a lot of the people here are in the public health space, and in the public health space, one of the big things you need is information on the local population. Therefore, we spend a lot of time using the census. However, as the person who first went when talking about NHANES, government's great at gathering data, not so much at putting it on the internet in an easily accessible way. If you try to use the census website, it's pretty terrible. So what I wanted to show you is how to use the tidycensus package to access the census data really easily. And then once we have that census data, we're going to do a bit about playing around with geospatial data more generally, showing you how you can easily project it and some easy ways to manipulate it. Because your data probably has geospatial components in it. And if you're not using them, the goal of this is to make you know how you can, and to give you a piece of code, which at the end, you can easily Frankenstein into something which works for you. So first things first, I'm going to load up all my packages. Tidyverse, just because it's basically base R now. Tidycensus. This is the package that we're going to be using to access the census through its API. SF. This is a package which is very useful for spatial data manipulation. There's going to be a lot of commands from this. GG themes. I did not actually end up using this one in here. I thought I was going to, but if you don't use it, it's just a really easy wrapper for your ggplot items to make them pretty. And GG spatial is good for manipulating base maps, which is surprisingly hard and why I'm gonna, at the end of this, talk about leaflet. So now we're gonna talk about census data manipulation. If you, dear listener, were running for this the first time, here's where you would load in your census API key. I have it set, so you put your key here, and I have it set install equals true. This will cache it on your computer and you won't have to run it again. However, this should still work for you even if you don't have a census API key, because you're allowed a certain number of pulls as an unidentified computer. But before we start pulling any data, we need to know what data we want to pull. And in order to know what data we want to pull, we need to know what data there is. From the tidycensus package, we're using the load variables command. This is going to tell it to go to the two things that we're specifying, a year and a census table. So we're saying 2022 ACS 5. And so when we run this, I'm going to have it also pop up what the ACS 5 of ours look like. We can see the variable name, the concept that it's pulling from, the subgroup estimate, and the geography to what we're in, that geography to which we're able to pull it. This is all useful information. What you're going to be using to pull the variables are these codes, and you're going to be wanting to make sure that whatever you're pulling them from is at a geography which is acceptable for your use, or if you're trying to join it with another one compatible with that set. Here's something that I previously assembled. It's kind of just like a trail mix of various socioeconomic variables. You'll see what I'm doing is I'm assigning a name to each of these codes. It just needs this number, but if you pull it with just this number, it will give you this number as a name, and I don't know what B01003 is. So by assigning it this way, it will automatically populate that name. So we're going to create our var list, and then we're going to use to get ACS, another one from the tidycensus package. There's going to be a couple things you have to specify. You're going to want to specify what geographic area you're wanting to look at. We're going to say tract. Variables, we've just established up here, as well as where you want to pull it. I'm from Rhode Island, so we're doing Rhode Island. The year, and geometry true, output wide. These are two interesting ones. These ones up here are all needed in order for it to know what to pull. These two aren't, but I want to talk about them anyways. Geometry true means it will pull from the tiger. I can't remember what it properly is, but it will pull in the United States geography with it. So it comes in as a shapefile. And then output wide, if you're pulling in geometry true, you really want to turn that on, because otherwise it will naturally come in a tidy format, which is great if you're trying to make simple plots, not very good for geospatial manipulation. So we're going to do that real quick, and it's going to take a second. And so now we have our RIY data. Let's take a quick look and see what we got. We got the GeoID, the name, all our different values. You can see for each one, it has the, what's it called? The estimate and the, I think that's the margin of error. So this is what they estimate the value to be, and this is an estimation of their confidence. And then you got your geometry, which is a series of points, which when assembled together will make your polygon. So with this, it's enough to make a map. Shove it into ggplot with your data set name, GeoMSF, it immediately can take that geometry and make a plot from it. It's not a very exciting plot though. There's no color. It basically is just telling us the outlines. So what do we want to do with that? Let's try to populate to make the fill actually mean something. So quick note, the reason why I'm starting showing it in ggplot, even though later I'm going to discuss the issues of it, is because I assume dear listener knows about ggplot and how to run it. So for someone who's never manipulated spatial data before, this is a real easy way to get it running. But anyways, so what we're going to do is we're going to add some fill based off the total population. This is just a color scheme I like and tossing on a label, but you really just need like the stuff that's not highlighted. That's a functional plot. But as we look at this, we see the issue of just using total population, which is that these areas are not equal. So what we're going to do is we're going to want to look at population, or want to look at population density. Now, as we noted when we looked at RI wide, it does not have area, but it does have a geometry. So we're going to pull from the SF package, and we're going to use ST area to automatically calculate our area. And then what we're going to do is we're going to calculate pop dense by taking the population estimate and dividing that by the area. To note, the population area automatically got estimated in square meters, so the units are very strange, but yeah. But now you're looking at this plot, makes a lot more sense, presents a lot more sensible image. If we zoom in on it, we can see, nope, move chart. We can see, I shouldn't have gotten squished. Here's Providence, here's Pawtucket, here's Woonsocket, and here's Newport. Those are kind of the big core cities. In Rhode Island, we joke how we're basically a city state, and you can kind of see why we make that joke. Great. So this map is better, but it doesn't have a base map. And without a base map, it just doesn't look quite as nice. So now we are going through the GG spatial, and we're just using annotation map tile. What this is going to do is it's going to detect based on the area defined by RI wide and set a base map for that. You want to make sure whenever you're pulling in a base map, it's the furthest down layer, because otherwise it will project over everything else. But when you toss that in and you remember to hit the button twice, you can pop up with this. A second, like that. So now you have your map with your weighted variable projected as a choropleth on a base map. However, you want to use more than just the ACS data. You're going to want to be pulling in other layers, and a lot of those other layers are going to be coming from Esri. It's one of the big players in the GIS world. So I wanted to show you a couple ways that you can pull in data from Esri's API links. At Rhode Island, we have RIGIS as our source. No, I need to see my variable list. Sorry. So here at RIGIS, let me see if I can see it. They have an I want to use the data button. And from this, I can find the API of it. I previously pulled it into here. And what I found is you can just run stread on that API link, and it will automatically pull in your layers. So here we did it for Zictas, and we can see we got all the different Zicta layers, as well as a geometry. But now to the important things. So here's an example of one where it didn't work for me immediately, and I spent like 30 minutes feeling like a fool until I figured it out. So what you see is here, when we tried to run it, it gave us an error. And here is what I found with this error. When you look at these URLs, this bit is all directing you to a feature, to like basically where the layer is. But this one, this is from a different source, is automatically truncated. I'll show you about that source. Here, if someone is trying to use Esri data, we'll have this as a separate conversation. But when you're pulling Esri data, you'll eventually get to a point where you pull this URL. This URL, however, this is what I've realized, does not actually contain any query information. Query outfields star means pull all the fields F format GeoJSON. This one didn't automatically have that when I pulled it over. So I just kind of stole it from the other one and automatically attached it. Basically, this was sending someone to the grocery store, but not giving them a list of anything to get. So it got there perfectly fine, and it came back without any requests. But so now I fixed it, or now I'm fixing it, and now I'm pulling it, and now it works great. So let's take a quick look at it. Well, as we can see, it pulled in the layer, but it did not do what I wanted because I'm only interested in Rhode Island. And it pulled in everything. So we're going to have to then subset it. Now, there is a way to do so via the API link in this query section, but I have not bothered figuring that out because I'm not dealing with larger enough data sets. But if you have a large one, you might need to. However, we're going to do a quick clean, and then we're going to do a quick projecting. And now we can see it works great. So now we have the points of Dunkin' Donuts overlapping the choropleth map of the state and a base map. To make a quick note of how we're pulling in two different spatial data sets. Here I am redefining the data. I'm pulling down from plot 1, which I last saved here. So basically I'm adding onto this bit, no, not that bit, this bit, yeah, that bit. The additional command of, now I need to find where I am, sorry, I got lost, of add a geo-shaped file from the data of Dunkin' Donuts. That will automatically tell it to use the geometries. However, I don't really like this. Because when you're looking at it, you see that it makes it basically just makes it kind of hard to read what's going on in the downtown Providence area. You're going to get a lot of overlapping dots, so it gets a bit messy. So what we want to do is we want to take these points and convert them to, or add them to these polygons and then calculate density for, or calculate a count for them. I don't think I actually did density. So let's see, what did I last row? Okay. So first things first, I want to try to do a join of them, but egads, it did not work. So what's going wrong here? What you're seeing is STCRS is not true for them equaling one another. What is that? So CRS stands for Coordinate Reference System. Basically, it is how do we define what the globe is? And there's a couple different ones because the globe is not a perfect sphere. So of course, there have been multiple iterations as we've gotten better, but also you'll oftentimes have specific area ones for different slices of the world. Like this one's the World Geodetic System, so it's supposed to project for the entire world, but the other one, which I know because I've been playing with this is the NAD, which is North American datum, which is one specifically made to work best on the North American continent. But so in order for this to join, we need to set them equal. To note, you want to do this ST transform, not just set ST equal, because if you do that, it will coerce it and you'll get frame shift mutations. So we're going to fix that. And then we're going to join that. And then we're just going to group by summarize basically the count based on the GeoID to see how many are in each of these counts. And then for our last projection, we're going to see the count map. This is also to note count, not density. But you can see there is a ton right in downtown Providence and in the areas where people have to drive more. But yeah. So that's how you import census data, how you transform that census data into a map, and then how you can take other points from other APIs, pull them in, and then how you can join that along with the other census data. Last but not least, I'm going to touch on leaflet. So the reason why I kind of have this separated out as its own bit is I don't personally do a lot with leaflet since I also use Esri. And the big thing that leaflet gives you, one is for some reason, base maps are surprisingly difficult in ggplot. Like it doesn't make any sense to me. It's mostly just, there are the same 3 wrong Google answers, which always pop up to the top of the list. But leaflet's really great for making nice interactive plots. And when you're making a map, having it be interactive just makes it so much more nicely tactile and people love that. So just a quick example of what you can do with leaflet and what those look like, mostly for your knowledge, not as a good example. Here, what you can see we've done is we pull in the RIY data set, told it to populate polygon or tiles, which is the background, and then said to add the polygons. We then also said to quickly add a little pop-up based on 2 different names. Am I out of time, Tessa? Are you hammering me?
Well, we have about 1 minute to do a raffle and choose the best speaker and
well, then I'm
online raffle.
I'm going to stop then there, but send this around to them. Have a great day.
Thank you so much, Robert.